Hello, in this lecture we will find the radius of the circle. In the drawing we have a circle, and inside this circle we have quadrilateral ABCD. Quadrilateral ABCD is inscribed by this circle, and we know that side AB equals to 3 units, so we will define side AB as A, and we know that A equals to 3 units. A equals to 3 units, and we also know that side BC of quadrilateral ABCD equals to 4 units. We define side BC as B, therefore B will be equal to 4 units. And we will also define, we know that side CD of quadrilateral ABCD equals to 5 units. We will define side CD as C, therefore C will be equal to 5 units. And we also know that side AD of quadrilateral ABCD equals to 6 units, so we will define side AD as D, and we know that D equals to 6 units according to what is given us in the question. We want to find out the radius of this circle that blocks quadrilateral ABCD. Okay, so first of all I will present to you three new rules, and we will implement the rules in our drawing. So the first rule will be rule number 1. Actually, rule number 1 states that the area of a quadrilateral inscribed by a circle equals to the area of quadrilateral ABCD. Actually, this is the sign for the area of triangle ABCD. This means the area of triangle ABC. So the area of triangle ABCD and the area of quadrilateral ABCD, the area of this quadrilateral or any other quadrilateral equals to, if we know that the quadrilateral is inscribed by a circle, then the area of that quadrilateral will be equal to the root of S minus A. As you can see here, A, B, C, and D are the lengths of the quadrilateral sides. For example, A is the length of side AB of quadrilateral ABCD, and again BC, the B is the length of side BC of quadrilateral ABCD, and also C and D in the same way. So the area of quadrilateral ABCD equals to S minus A times S minus B times S minus C times S minus D. Again, A, B, C, and D are the lengths of quadrilateral ABCD, and S equals to the sum of the sides of quadrilateral ABCD. So it equals to A plus B plus C plus D over 2. Okay, so whenever you have a quadrilateral that it is inscribed in a circle or bicircle, then the area of that quadrilateral will be equal to the root of S minus A times S minus B times S minus C times S minus D, and A, B, C, and D are the lengths of the quadrilateral sides, and A and S equals to the sum of its sides over 2. So A, B, C, A plus B plus C plus D over 2. Okay? So that is rule number 1. I will draw the quadrilateral ABCD, that could be any quadrilateral. So the area of quadrilateral ABCD, that could be any quadrilateral, we know that side AB equals to A units in its size, side BC of quadrilateral ABCD equals to V units in its size, side CD of quadrilateral ABCD equals to C units in its size, and side AD of quadrilateral ABCD equals to D units in its size, and the area of this quadrilateral ABCD that is inscribed in this circle will be equal to the root of S minus A times S minus B times S minus C times S minus D, when A, B, C, and D are the lengths of these quadrilateral sides, and S equals to the sum of its sides over 2, that is to say S equals to A plus B plus C plus D over 2. Okay? For any quadrilateral that is inscribed by a circle, this will be the area of it, of this quadrilateral, when S equals to A plus B plus C plus D over 2. Okay, so that is rule number 1, and we also have rule number 2. According to rule number 2, rule number 2 states that if a quadrilateral is inscribed by a circle, then the product of its sides equals to the sum of the products of the quadrilateral is inscribed by a circle, then the quadrilateral, then the product of its sides equals to the sum of the products of its opposite sides. I will read rule number 2 again. Rule number 2 states that if a quadrilateral is inscribed by a circle, then the product of its sides equals to the sum of the products of its opposite sides. So what is the meaning of rule number 2? The meaning of rule number 2 is that if you have this circle and inside this circle we have quadrilateral, it is inscribed by this circle, so quadrilateral ABCD, this quadrilateral is inscribed by this circle. We know that side AB equals to A units in its size, side BC equals to B units in its size, side CD of quadrilateral ABCD equals to C units in its size, and side AD of quadrilateral ABCD equals to D units in its size, and a quadrilateral ABCD have its two diagonals, diagonal PD of quadrilateral ABCD equals to X units in its size, that is to say BD equals to X units, and we also know that diagonal DC of quadrilateral ABCD, this diagonal AC equals to Y units in its size, that is to say AC equals to Y units. Then according to rule number 2, if we have this quadrilateral that is inscribed in this circle, then according to rule number 2, the product of its diagonals, we have diagonal BD and diagonal AC. The product of its diagonals is actually X times Y. The product of its diagonals is X times Y, equals to, according to rule number 2, it equals to the sum of the products of its opposite sides. The quadrilateral ABCD has two opposite sides. Side BC is opposite to side AD, and side AB is opposite to side DC. And the product of the opposite sides, the first product of the first opposite sides is B times D, and the second product of the other two opposite sides is A times C. And according to rule number 2, the product of its diagonals, that is to say x times y, equals to the sum of the products of its opposite sides. The first product is BD and the second product is AC. And the sum of the product of its opposite sides is BD plus AC, and according to rule number 2, the sum of the product of its opposite sides BD plus AC equals to the product of its diagonals, that is to say it equals to x times y. Again, the product of diagonals A, B, C, D is x times y, and that product equals to the sum of the product of its opposite sides. We have two products of its opposite sides, product BD and product AC, and the sum of the product of the diagonals opposite sides is actually the first product BD plus the second product AC. So the sum of its product of its opposite sides is BD plus AC, and it equals to the product of its diagonals, that is to say it equals to x times y. Okay? Again, if a quadrilateral, like this quadrilateral is inscribed by a circle, this quadrilateral ABCD is inscribed by a circle, then the product of its sides, that is to say x times y, equals to the sum of the products of its opposite sides. And the sum of the products of its opposite sides is BD plus AC. So in total, x times y, the product of its diagonals, equals to the sum of the products of its opposite sides. That is to say, it equals to BD plus AC. Again, xy equals to BD plus AC. The product of its sides, that is to say x times y, equals to the sum of the product of its opposite sides. That is to say, it equals to BD plus AC. Okay? So actually that is rule number 2, and we also have rule number 3. Rule number 3 states that if a triangle is inscribed by a circle, then the radius of that circle equals to the product of the triangle's sides of that triangle sides over 4 times the area of that triangle. 3 again. Rule number 3 states that if a triangle is inscribed by a circle, then the radius of that circle that inscribes the triangle equals to the product of that triangle sides over 4 times the area of that triangle. Okay, so what is the meaning of rule number 3? The meaning of rule number 3 is that if you have this circle and inside this circle we have a triangle, or this triangle blocks, this circle blocks a triangle, or triangle ABC is inscribed in this circle. If we have a triangle that it is inscribed in this circle, like this triangle ABC, we have this triangle ABC is inscribed in this circle, and we know that side AB of triangle ABC equals to A units in its size, side BC of triangle ABC equals to B units in its size, and side AC of triangle ABC equals to C units in its size. So if we have a triangle that is inscribed by a circle, like in this drawing, then the radius of this circle, that is to say R, equals to the product of the triangle sides. The product of triangles ABC sides is actually A times B times C over 4 times the area of the triangle, over 4 times the area of this triangle, triangle ABC. Okay, so whenever you have a triangle that is inscribed by a circle, like in this drawing, then the radius of this circle will be equal to the product of triangles ABC sides, that is to say it will be equal to A times B times C over 4 times the area of this triangle, triangle ABC. Okay, the radius of this circle equals to ABC over 4 times the area of triangle ABC according to rule number 3. Okay, so whenever you have a triangle that is inscribed in a circle, like in this drawing, then the radius of this circle will be equal to the product of the triangle sides, in this case is A times B times C, over the area of the triangle that it is inscribed by the circle, over 4 times the area of triangle ABC in this case. Okay, so that is rule number 3, and in the next step we will implement all the 3 rules in our drawing. So first of all, we will draw the 2 diagonals of quadrilateral ABCD. The first diagonal will be diagonal BD, and we will define diagonal BD as X, that is to say BD equals to 8 units, so the size of BD is X units. And we will define diagonal AC, the second diagonal of quadrilateral ABCD, as Y. Okay, that is to say AC equals to Y, or the size of diagonal AC equals to Y units, or AC equals to Y units in its size, and BD equals to X units in its size. Okay, and then we will implement all the 3 rules that I presented to you in our drawing. the first rule was that the area of this quadrilateral ABCD equals to the root of S minus A times S minus B times S minus C times S minus D, when A, B, C, and D are the lengths of these quadrilateral sides, and S equals to A plus B plus C plus D over 2. So that is rule number 1. And rule number 2, we'll implement rule number 2 in our drawing. Rule number 2 states that if we have a quadrilateral that is inscribed in a circle like in our drawing, then the product of its diagonals, that is to say x times y, equals to the sum of the products of its opposite sides. That is to say, it will be equal to AC plus BD. AC plus BD, that is the implementation of rule number 2 in our drawing. And we also have rule number 3. In rule number 3, we will focus on triangle ABC. As you can see from the drawing, that triangle ABC, this triangle is inscribed by this circle. Therefore, according to rule number 3, the radius of this circle that blocks triangle ABC, this triangle will be equal to the product of triangles ABC sides, that is to say, to A times B times Y, over 4 times the area of triangle ABC. Okay, actually, equation number 3, this equation is the implementation of rule number 3 in our drawing if we relate to triangle ABC. If we relate to triangle ABC, we know that this triangle ABC is inscribed by this circle. Therefore, according to rule number 3, the radius of this circle will be equal to the product of triangles ABC sides, that is to say, it will be equal to A times B times Y, over 4 times the area of triangle ABC. That is rule number 3. Okay, so here we will multiply equation number 3 by the area of triangle ABC, and we will get that R times the area of triangle ABC will be equal to ABY over 4. Okay, we got that R times the area of triangle ABC equals to ABY over 4. Here we will divide equation number 3 by R, and we will get that the area of triangle ABC equals to, according to equation number 3, the area of triangle ABC equals to ABY over 4R. So found out the area of triangle ABC. In the next step, we will focus on triangle ADC. We will focus on triangle ADC. As you can see from the drawing, this triangle ADC is inscribed by this circle. Again, triangle ADC, this triangle is inscribed by this circle. Therefore, whenever you have a triangle that it is inscribed by a circle, we can implement rule number 3 that states that the radius of that circle that blocks triangle ADC will be equal to the product of triangle ADC sides. The product of triangle ADC sides is C times D times Y. C times D times Y over 4 times the area of triangle ADC. That is the implementation of rule number 3 in our drawing, and if we relate to triangle ADC, it is blocked by this circle. So here we will multiply equation number 4 by the area of triangle ADC, and we will get that R times the area of triangle ADC equals to C dy over 4. Here we will divide the equation number 4 by R, and we will get that the area of triangle ADC equals to C dy over 4R. We actually found out the areas of triangle ADC and the area of triangle ABC. But as you can see from the drawing, the area of triangle ABC plus the area of triangle ADC equals to the area of triangle of quadrilateral ABCD, because of the fact that quadrilateral ABCD consists exactly those two triangles. Therefore, the area of quadrilateral ABCD will be the sum of the areas of triangle ABC plus the area of triangle ADC. So we write it down. That will be equation number 1, that the area of quadrilateral ABCD, the area of this quadrilateral will be equal to the area of triangle ABC, this triangle, plus the area of triangle ADC, this triangle. It is very easy to see that the sum of the areas of those two triangles equals exactly to the area of quadrilateral ABCD. Okay, so the area of quadrilateral ABCD equals to the area of triangle ABC plus the area of triangle ADC. Okay. So the area of quadrilateral ABCD, we've already found out the areas of triangle ABC and the area of triangle ADC. So we substitute the area of triangle ABC by the value that we found for the area of triangle ABC. We've already found out that the area of triangle ABC equals to ABY over 4R. And we've already found out that the area of triangle ADC equals to C dy over 4R. So here we will take out y over 4R as a common factor of this expression, and we will get that the area of quadrilateral ABCD equals to y over 4r is a common factor, and inside the brackets we will have here AB, and here what is left is, after we took y over 4r as a common factor, what is left is CD. So in total we found out that the area of quadrilateral ABCD equals to y over 4r times AB plus CD. Okay, so in the next step we will focus on triangle BDC. Triangle BDC as you can see from the drawing, this triangle BDC is inscribed by this circle. Therefore, we can implement rule number 3 in this triangle BDC that is inscribed by this circle. According to rule number 3, the radius of this circle that blocks triangle BDC will be equal to, this will be question number 5, the radius of this circle that blocks triangle BDC will be equal to the product of triangle BDC sides, that is to say it will be equal to B times C times X over 4 times the area of triangle BDC. So actually equation number 5 is the implementation of rule number 3 in our drawing if we relate to triangle BDC that is inscribed by the circle. Okay, this is the radius of the circle according to rule number 3. Here we will multiply equation 5 by BDC, and we will get that according to equation number 5, R times the area of triangle BDC equals to BCX over 4. Here we will divide equation number 5 by R, and we will get the area of triangle BDC. The area of triangle BDC according to equation number 5 equals to BCX over 4R. So we found out the area of triangle BDC equals to BCX over 4R. And in the next step we will focus on this triangle ABD. Okay, so in triangle ABD, as you can see from the drawing, this triangle ABD is inscribed by this circle. Triangle ABD inscribed by this circle. Therefore, we can implement rule number 3 in relation to triangle ABD, that it is inscribed by this circle. According to rule number 3, the radius of this circle that blocks triangle ABD will be equal to the product of triangle ABC sides, that is to say it will be equal to A times D times X over 4 times the area of triangle ABD. So actually, equation number 6 is the implementation of rule number 3 in our drawing in relation to triangle ABD that is inscribed by this circle. Therefore, the radius of the circle will be equal to ABX over 4 times the area of triangle ABD. Here we will multiply equation number 6 by the area of triangle ABD. And we will get that R times the area of triangle ABD equals to ADX over 4. Here we will divide the equation number 6 by R and we will get the area of triangle ABD. The area of triangle ABD according to equation number 6, it is actually equals to ADX over 4R. That is the area of triangle ABD. And we have already found out in equation number 5 that the area of triangle BDC is actually equals to BCX over 4R. Okay, so we actually have the areas of triangle ABD, this triangle, and triangle BDC. But as you can see from the drawing, quadrilateral ABCD consists of those two triangles. Therefore, the area of quadrilateral ABCD will be equal to the area of triangle ABD plus the area of triangle BDC. So I will write it down. This will be our second equation, that the area of quadrilateral ABCD will be equal to the area of triangle ABD plus the area of triangle BDC. I repeat again, the area of quadrilateral ABCD will be equal to the area of triangle ABD plus the area of triangle BDC. But we have already found out the areas of triangle ABD and the area of triangle BDC, so we'll substitute ABD and BDC by the areas that we found out for triangle ABD and for triangle BDC. Okay. So according to the second equation, the area of quadrilateral ABCD equals to the area of triangle ABD. We have already found out that the area of triangle ABD equals to ADX over 4R plus the area of triangle BDC, but we have already found out that the area of triangle BDC equals to BCX over 4R. So here we will take x over 4R as a common factor of this expression, and we will get that the area of quadrilateral ABCD equals to, we'll take a common factor of x over 4R out of these expressions, and what left inside the brackets, what is left here in this expression is AD, and what is left after we took a common factor of x over 4R out of these expressions, what is left is BC. So we actually found out that the area of quadrilateral ABCD equals to x over 4R times AD plus BC. But we have already found out that the area of quadrilateral ABCD is also equal to y over 4r times AB plus CD. So we actually have two expressions for the area of quadrilateral ABCD. Expression 1 and expression 2. So we will multiply equation 1 by equation 2. We will get equation number 3. That will be the area of quadrilateral ABCD squared. And it will be equal, if you multiply equation number 1 by equation number 2, it will be equal to x times y over 4r squared here we will have AD plus BC times AB plus CD. So here we'll take a root out of this equality, equation number 3, and we will get that the area of quadrilateral ABCD equals to the root of this expression equals to xy AD plus BC times AB plus CD. Over, so the root of 4r squared is 4r because the root cancels the square. The root of 4r squared is 4r. We got this expression. So here we will multiply equation number 3 by r, and then we will divide it by the area of quadrilateral ABCD. So first of all we will multiply it by r. We will get that r times the area of quadrilateral ABCD equals to the root of xy AD plus BC times AB plus CD. Here we will divide equation number 3 by the area of triangle A, by the area of quadrilateral ABCD, and we will get that the radius that we are looking for of the circle equals to the root of xy times AD plus BC times AB plus CD over 4 times the area of quadrilateral ABCD. So, first of all, we know that according to rule number 2, x times y equals to AC plus BD. Therefore, we can substitute xy in equation number 3 by AC plus BD, because AC plus BD equals to xy. So we will do it now. We'll substitute xy by AC plus BD. So equation number 3 will be that the radius of the circle equals to the root of, we substitute xy by AC plus BD, then we multiply it by AD plus BC, multiplied by AB plus CD. All divided by 4 times the area of quadrilateral ABCD. Okay. Actually, we know the values of A, B, C, and D. The only thing that is left to find in order to find out the radius of the circle is to find out the area of quadrilateral ABCD. And we already found out the area of triangle of quadrilateral ABCD. According to rule number 1, the area of quadrilateral ABCD equals to the root of S minus A times S minus B times S minus C times S minus D. A, B, C, and D are the lengths of quadrilateral ABCD sides, and S equals to A plus B plus C plus D over 2. That is to say, S equals to A. I will write it down here that A equals to 3 units, B equals to 4 units, C equals to 5 units, and D equals to 6 units. So here we get that A plus B is 3 plus 4 is 7 plus 5 is 12, and 12 plus D, that is 6, is 18, and 18 over 2 is 9. So we found out that S equals to 9. So we substitute S in this equality by 9, because S equals to 9, and we will get that the area of quadrilateral ABCD equals to the root of S is 9, A is 3, so it is 9 minus 3 times S is 9, B is 4, so it is 9 minus 4, S is 9, C is 5, 9 minus 5, S minus D is 9 minus 3. So the area of quadrilateral ABCD equals to the root of 9 minus 3 is 6 times 9 minus 4 is 5 times 9 minus 5 is 4, and 9 minus 3 is 6. Okay, so we got that the area of quadrilateral ABCD equals to the root of 6 times 5 is 30, 30 times 4 is 120, and 120 times 9 times 9 minus 6 is 3 here. 9 minus 3, 9 minus 6 is 3. So 6 times 5 is 30, and 30 times 4 is 120, and 120 times 3 is 360. So we found out that the area of quadrilateral ABCD equals to the root of 360 square units. And the radius of the circle, according to equation number 3, equals to the root of AC plus BD times AD plus BC times AB plus CD. All divided by 4 times the area of quadrilateral ABCD. That is actually the root of 360. So the radius of the circle, according to equation number 3, equals to, so here I will write down that C equals to 3 units, A equals to 3 units, B equals to 4 units, C equals to 5 units, and T equals to 6 units. So we get that the radius of the circle equals to AC, A is 3, C is 5, so it is AC is 15, plus BD, B is 4, D is 6, 4 times 6 is 24, times AD, A is 3, D is 6, 3 times 6 is 18, plus BC, B is 4, C is 5, 4 times 5 is 20, times AB, A is 3, B is 4, 3 times 4 is 12, plus CD, C is 5, D is 6, 5 times 6 is 30, and all divided by 360, and it is divided also by 4. So here we get that the radius of the circle, first of all, we have here 1/4 times the root of 30 plus 24 is 15, plus 24 is 39. 39, 18 plus 20 is 38, and 20 plus 12 plus 30 is 42 over 360. Okay, so we got that the radius of the circle equals to this expression inside the root equals to 172.9. So it is the root of 172 over 4 units. So we actually found out that the radius of the circle equals to the root of 172.9 over 4 units. So in terms of numbers, the radius of the circle equals to 3.287 units. Okay, I will repeat again. The radius of this circle equals to either to the root of 172.9 over 4 units, or in terms of numbers, the radius of this circle will be equal to 3.287 units, about 3.3 units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the radius of this circle. Quadrilateral ABCD is inscribed by this circle, and we know that side AB equals to 3 units, side BC equals to 4 units, side CD equals to 5 units, and side AD equals to 6 units. We defined AB as A, so A equals to 3. We defined BC as B, B equals to 4. We defined side DC of quadrilateral ABCD as C, so C will be equal to 5 units, and we defined side AD of triangle of quadrilateral ABCD as D, so D will be equal to 6 units, according to what is given us in the question. And then we want to find out the radius of this circle that blocks quadrilateral ABCD, or quadrilateral ABCD is inscribed by this circle. We want to find out the radius of this circle. Okay. I presented to you three new rules, and we implemented those 3 new rules in our drawing in order to find out the radius of this circle. Rule number 1 was that the area of a quadrilateral inscribed by a circle equals to, this is the sign of the area of quadrilateral ABCD. This is how you write down the area of triangle ABCD. The area of quadrilateral ABCD equals to the root of S minus A times S minus B times S minus C times S minus D, when A, B, C, and D are the lengths of the sides of quadrilateral ABCD. So you can see side AB equals to A units in its size, side BC equals to B units in its size, side CD equals to C units in its size, and side AD of quadrilateral ABCD equals to D units in its size. So, and S equals to A plus B plus C plus D over 2. So, whenever you have a quadrilateral that is inscribed by a circle, like in this drawing, then the area of this quadrilateral ABCD will be equal to the root of S minus A times S minus B times S minus C times S minus D, when A, B, C, and D are the lengths of these quadrilateral sides, and S equals to A plus B plus C plus D over 2. Okay? So this is rule number 1, and I presented to you also rule number 2. Rule number 2 states that if a quadrilateral is inscribed by a circle, then the product of its sides equals to the sum of the products of its opposite sides. So we have a quadrilateral ABCD that is inscribed by this circle, and we have 2 diagonals inside quadrilateral ABCD diagonal AC equals to y units in its size, and diagonal BD equals to x units in its size. And actually the product of the diagonals in a quadrilateral that is inscribed by a circle equals to x times y, and that product x times y equals to the sum of the products of its opposite sides. The first product of its opposite sides is b times d, and the second product of its opposite sides is a times c, and the sum of the products of the opposite sides is BD plus AC. And according to rule number 2, the product of its diagonals, that is to say x times y, equals to the sum of the products of its opposite sides. That is to say it equals to BD plus AC. Okay, again, the product of the quadrilateral that is inscribed in a circle, the product of the diagonals of quadrilateral that is inscribed by a circle is x times y, and that product equals to the sum of the products of its opposite sides, and the sum of the products of its opposite sides is BD plus AC. So x times y, the product of the quadrilateral diagonals, equals to the sum of the products of its opposite sides. It equals to BD plus AC. Okay, the first product of its opposite sides is BD, and the second product of its opposite sides is AC, and the sum of the products of its opposite sides is BD plus AC, and that product equals to the products of its diagonals, that is to say it equals to x times y. Okay? If a triangle is inscribed by a circle, like in this drawing, we have, if a quadrilateral ABCD is inscribed by a circle, like in this drawing, then the product of its sides, the product of its diagonals, that is to say, the product of its diagonals, the product of its diagonals, the product of its diagonals is actually x times y, and the product of its diagonals equals to the sum of the products of its opposite sides. So the sum and the product of its diagonals is x times y, and that product equals to the sum of the products of its opposite sides. The first product of the quadrilateral opposite sides is b times d, and the second product of this quadrilateral opposite sides is a times c, and the sum of the products of its opposite sides is BD plus AC, and that sum of the product of its opposite sides equals to the product of its diagonals, that is to say it equals to x times y. So x times y, the product of its diagonals, equals to the sum of the products of its opposite sides, that is to say it equals to BD plus AC. Okay? Okay, if you have a quadrilateral that is inscribed by a circle, like in this drawing, then the product of its diagonals, that is x times y, will be equal to the sum of the products of its opposite sides. That is to say, it will be equal to BD plus AC. That is rule number 2. And we also have rule number 3. According to rule number 3, if a triangle is inscribed by a circle, like in this drawing, we have triangle ABC that is inscribed by this circle, then the radius of that circle, the radius of this circle that blocks triangle ABC equals to the product of the triangle sides. The product of triangles ABC sides is A times B times C over 4 times the area of that triangle, over 4 times the area of triangle ABC. So whenever you have a triangle like in this drawing that is inscribed by a circle, then the radius of this circle will be equal to the product of the triangle that is inscribed by this circle. That is to say, it will be equal to the product of triangles ABC sides. That is to say, it equals to A times B times C over 4 times the area of the triangle that is inscribed by that circle. That is to say, it equals to over 4 times the area of this triangle, triangle ABC. So the radius of a circle that is the radius of a circle that blocks a triangle equals to the product of the product of the sides of the triangle. If a triangle is blocked by a circle, the radius of that circle will be equal to the product of the triangle sides. That is to say, in this example, it will be equal to A times B times C over 4 times the area of the triangle that is blocked by that circle. It will be equal to ABC over 4 times the area of the triangle that is blocked by this circle. Okay, so if you have a triangle that is inscribed by a circle, you can know the radius of that circle that blocks that triangle by knowing the sides of the triangle that is blocked by that circle. So R, the radius of a triangle that blocks this triangle, will be equal to the product of its sides. That is to say, it will be equal to A times B times C over 4 times the area of the triangle, triangle ABC. Okay, so R equals to ABC over 4 times the area of the triangle, triangle ABC. This is all number 3. Then we implemented all the 3 rules that I presented to you in our drawing. Actually, the area of this quadrilateral that is inscribed by this circle equals to the root of S minus A times S minus B times S minus C times S minus D, when A, B, C, and D are the lengths of the quadrilateral sides, and S equals to A plus B plus C plus D over 2. This is according to rule number 2, and we implemented rule number 2 also in our drawing. According to rule number 2, if a quadrilateral is inscribed by a circle like this, like in our drawing, then the product of its diagonals, that is to say x times y, equals to the sum of the products of its opposite sides. So x times y equals to BD plus AC. X times y equals to BD plus AC. Okay, or x times y equals to AC plus BD. This is the implementation of rule number 2 in our drawing, and the implementation of rule number 3 in our drawing is if we relate to triangle ABC, triangle ABC is blocked by this circle, or triangle ABC is inscribed by this circle. Therefore, according to rule number 3, the radius of this circle that blocks triangle ABC will be equal to the product of triangles ABC sides. That is to say, it will be equal to A times B times Y over 4 times the area of triangle ABC. So the radius of the circle that blocks triangle ABC will be equal to the product of triangles ABC sides. That is to say, it equals to A times B times Y over 4 times the area of triangle ABC. That is according to rule number 3. Here we multiplied equation number 3 by the area of triangle ABC, and we got that R times the area of triangle ABC equals to ABY over 4. We divided the equation over 3, this equation, by R, and we got that the area of triangle ABC equals to ABY over 4R. Okay, then we relate it to triangle ADC. As you can see from the drawing, this triangle ADC, is blocked, is inscribed by a circle, or the circle blocks this triangle. Therefore, according to rule number 3, the radius of this circle will be equal to the product of its sides. That is to say, it will be equal to C times D times Y. C times D times Y over 4 times the area of triangle ADC. Over 4 times the area of triangle ADC. So here we multiply the equation number 4 by the area of triangle ADC. We got this equation, and we divided this equation by R, and we got that the area of triangle ADC equals to CDY over 4R. Okay? So actually the area of quadrilateral ABCD equals, it consists of two triangles. Therefore the area of quadrilateral ABC will be equal to the area of triangle ABC plus the area of triangle ADC. Okay? The area of quadrilateral ABCD equals to the area of triangle ABC plus the area of triangle ADC. Okay? But we have already found out that the area of triangle ABC equals to ABY over 4R, and the area of triangle ADC equals to CDY over 4R. We took a common factor out of this expression, common factor y over 4R, and we got that the area of quadrilateral ABCD equals to y over 4R times AB plus CD. Okay, so in the next step, we focused on triangle BDC, on this triangle. This triangle BDC, is inscribed by this circle. Therefore, according to rule number 3, the radius of this circle will be equal to the product of triangles BDC sides. That is to say, it will be equal to BCX. It will be equal to BCX over 4 times the area of triangle BDC. Here we multiplied equation number 5 by the area of triangle BDC, and we got this equation. Then we divided equation number 5 by R, and we got that the area of triangle BDC equals to BCX over 4R. Okay, then we focused on triangle ABD. On this triangle ABD is inscribed by this circle. Therefore, according to rule number 3, the radius of this circle that blocks this triangle ABD will be equal to the triangles, the product of the triangle sides. That is to say, it will be equal to A times D times X. It will be equal to A times D times X over 4 times the area of triangle ABD. Okay? Then we multiply the equation number 6 by the area of triangle ABD. We got this expression, and we divided this equation by R, and we got that the area of triangle ABD equals to ABX over 4R. And we have already found out that the area of triangle BDC equals to BCX over 4R. Okay? And we know that the area of quadrilateral ABCD, the area of quadrilateral ABCD equals the area of quadrilateral ABCD equals to the area of triangle ABD plus the area of triangle BDC. Okay? The area of quadrilateral ABCD equals to the area of triangle ABD plus the area of triangle BDC. But we have already found out that the area of triangle ABD equals to ABX over 4R, and the area of triangle BDC equals to BCX over 4R. Here we took a common factor of x over 4R out of these expressions, and we got this equation. So we actually found out that the area of quadrilateral ABCD equals to x over 4R times AB plus BC. And we have already found out that the area of quadrilateral ABCD equals to y over 4r times AB plus CD. Then we multiplied equation number 1 by equation number 2, and we got equation number 3, that is actually the area of quadrilateral ABCD squared. It equals to this expression, that is the multiplication of those two expressions. And here we took a root out of this equation number 3, and we got that the area of quadrilateral ABCD equals to the root of this expression over 4r, because the root of 4r squared equals to 4r. Here we multiplied this equation number 3 by r, and we got this expression. Then we divided this equation number 3 by the area of quadrilateral ABCD, and we got that the radius that we are looking for equals to this expression. Then we have already known that according to rule number 2, xy equals to AC plus BD, so we can substitute xy by AC plus BD in this equation number 3. So we substituted xy by AC plus BD, and we got this equation. Then we found out that the area of quadrilateral ABCD according to rule number 1 equals to this expression, and S equals to A plus B plus C plus D over 2. We know that A equals to 3, B equals to 4, C equals to 5, and D equals to 6. So therefore S will be equal to 9 units. So we substituted S in this equality by 9, because S equals to 9. And we know that A equals to 3 units, B equals to 4 units, C equals to 5 units, and D equals to 6 units. So we substituted A, B, C, D by their values, and we got this expression. And we did the subtractions, and we got this expression that the area of quadrilateral ABCD equals to the root of 6 times 5 times 4 times 3. That is actually 360. So we got that the area of quadrilateral ABCD equals to the root of 360. So we can substitute the area of quadrilateral ABCD in equation number 3 by the root of 360, because it equals to the root of 360. So we substituted the area of quadrilateral ABCD by the root of 360, and we got this expression. Here we know that all the values of A, B, C, and D. So we put the data inside this equality, and we got this expression. 15 plus 24 is 39, 18 plus 20 is 38, and 20 plus 30 is 42, all over 360. And the root, the expression inside the root, equals to 172.9 all divided by 4. So we found out that the radius of the circle, the radius of this circle that blocks quadrilateral ABCD equals to either the root of 172.9 over 4 units, or in terms of numbers, the radius of this circle equals to 3.287 units. So I will repeat again, the radius of this circle that blocks quadrilateral ABCD equals to either to the root of 172.9 over 4 units, or in terms of numbers, the radius of this circle equals to 3.287 units. Okay, thank you very much.